are back with another projectiles example. Okay, this time we've got a particle projected with speed u at an angle of elevation alpha. And then we are told when the particle is moved a horizontal distance x, its height above the point of projection is y. And then we need to show that y equals x tan alpha minus gx squared over 2u squared bracket 1 plus tan squared. Let's give ourselves a little diagram of what's going on. So we're projected with initial speed u, our angle is alpha, and then at some point, okay, we've got horizontal distance x, and then our vertical displacement is y, or our vertical distance above the plane is y. Okay. So if we resolve vertically first of all, we know at this point our vertical displacement is y, our vertical component of the initial speed is u sine alpha. We don't know what our vertical velocity is at that point. Our acceleration is due to gravity, that's minus g. And our time, well, let's just say our time is t. Okay, so if we use s equals ut plus a half at squared to link those together, we've got y equals u sine alpha times t minus a half g t squared. So we've got the y equals, but not a lot else that looks similar. So what we're going to do, we can see here this doesn't have any t's in it. So we're going to resolve horizontally and get an expression that involves x, and then we're going to end up substituting that into here. So if we resolve horizontally, we know our horizontal displacement at this point is x. Our initial velocity horizontal component of this is u cos alpha. Our final will be the same, our acceleration will be 0, and t will be t because it's at the same time as at that point. Okay, so using s equals ut plus half at squared again, we get x equals u cos alpha times t. So if we rearrange this to make it t equals, we get t equals x over u cos alpha. And I'm going to substitute this expression for t into this one. And that'll give me, hopefully, with some manipulation, we'll get to that. So subbing in t as that, we get y equals u sine alpha times x over u cos alpha minus a half g times x over u cos alpha squared. Now these two u's will cancel each other out, and I've got sine alpha over cos alpha, which is tan alpha. So y equals x tan alpha. I've got the first bit, so happy days. Right, then let's work out what we get over here. So I'm going to write half g as g over 2, because I've got g over 2 here. And now I need to square everything in this bracket. So x squared at the top, and on the bottom, u squared cos squared alpha. Okay, I can bring the x squared and the u squared outside, because then I've got this first bit. Oh, that's not. That shouldn't be an equals, that's a minus. Okay, minus gx squared 2u squared plus 1 over cos squared. So let's just check. Well, we're not far away. All this first bit is correct. I've got 1 over cos squared. They've got 1 plus tan squared. So we just need to use a couple of trig identities to finish this off. Okay, so the first trig identity is that 1 over tan squared, 1 over cos squared is sec squared. So we can change that to sec squared alpha. That's the first one. Okay, 1 over cos is sec, 1 over cos squared is sec squared. And then the second trig identity is that sec squared is the same as 1 plus tan squared. Okay, remember sugar in your tea, sec squared equals 1 plus tan squared, and then we have, and then second part of the question, we have now been given the speed, so we know that u equals 28, we are given x is 32, and we are given y is 8. So subbing those into expression from part A, so let's just write that back out. Sub in all of those values there, so y is 8, x is 32, and we are trying to find alpha. Let's work out what this gives us. 8 equals 32 tan alpha minus 32 over 5, 1 plus tan squared alpha. Okay, so let's expand that, and then we'll get everything on one side. This times everything by 5, we get 32 tan squared alpha minus 160 tan alpha plus 72, and then we can divide everything by 8, and then we can solve this by using the quadratic formula, or we can factorize. Let's see if we factorize. We will need minus 9 and minus 1, so tan alpha equals a half, or tan alpha equals 9 over 2. So therefore alpha equals 27 degrees, or alpha equals 77 degrees to two significant figures.